Dear students, Namaste, good morning to you all, and also welcome to another session of our mathematics class. In the previous session, we have completed chapter number 8, that is Introduction to Trigonometry. Hope you have revised well. In today's session, we shall discuss chapter number 9 from NCERT textbook, Some Applications of Trigonometry. Let's move on to the topic. We all know that the height of Mount Everest is approximately 8,848 meters. And also know that the distance of Earth from Sun is approximately 151.85 million kilometers. Have you ever wondered how this height and distance was calculated? It is quite clear that these measurements cannot be taken by using a measuring tape. In both the cases, trigonometry was used for calculating the height and distance. In this lesson, let us learn how trigonometry is used to calculate the height and distance. Before solving the problems, let's discuss few important terms. The first one is horizontal level. A boy who is standing on the ground looking at some point on the tower. The line which connects his eyes and the point on the tower he observes is called the horizontal level. Remember, the horizontal level is always parallel to the ground. The line which connects the eye of the observer to the point on the tower or the point in which the particular observer observes is called the horizontal level. And please note that this horizontal level is always parallel to the ground. So, horizontal level is the line parallel to the ground passing through the observer's eye. The second point is line of sight. Consider a boy who is on the ground looking at some point on the top of the tower. The line which connects his eyes and the point he observes is called the line of sight. And you must note that the line of sight is not parallel to the ground. The line of sight is not parallel to the ground. But the horizontal level is always parallel to the ground and the line of sight is not parallel to the ground. And here the line which connects the eye of the observer to the point in which he observes is called the line of sight. So line of sight is defined as the line drawn from the eye of an observer to the point in the object viewed by the observer. This is a line which connects the eye of the observer and the point in the object viewed by the observer. The next point is angle of elevation. Suppose if we want to observe an object which is above our head, we must raise our head. For example, a boy who is standing on the ground observes an aeroplane which is flying in the sky. Here, the horizontal level goes this way. Horizontal level we have already discussed. The line which is parallel to the ground and passing through the eye of the observer. And the line of sight goes this way. The line of sight also we have discussed. It is a line connecting the eye of the observer and the point on the object. Here, angle of elevation means angle between the horizontal level and the line of sight. So, the angle of elevation of an object viewed is the angle formed by the line of sight with the horizontal when the object is above the horizontal. Remember this word, above the horizontal. Angle of elevation will be formed when the object is above the horizontal, or simply if you say that when the object is above our eye level. The next term we have to discuss is angle of depression. So if an object is below our head or below our eye level, we must lower our head to see that particular object. Here, a boy who is on the top of a building observes a basketball which is on the ground. His line of sight goes this way. This is the line of sight, and the horizontal level is like this. Horizontal level, we know that it is a line parallel to the ground and passing through the eye of the observer. And here also the definition is same, the angle between the horizontal level and the line of sight, provided the object is below the head or below the eye level, or simply if you say below the horizontal level. So the angle of depression of an object viewed is the angle formed by the line of sight with the horizontal when the object is below the horizontal. So here you must remember the word below the horizontal. So angle of depression will be formed when the object is below the horizontal, and angle of elevation will be formed when the object is above the horizontal. Move on to exercise questions. Exercise 9.1, question number 1. A circus artist is climbing a 20-meter long rope which is tightly stretched and tied from the top of a vertical pole to the ground. Find the height of the pole if the angle made by the rope with the ground level is 30 degrees. The first and foremost thing what we have to do is we have to form a right angle triangle. Here a circus artist is climbing a 20-meter long rope. The rope goes this way and the length of the rope is 20 meter and it is tied at both the ends. Here this is on the top of the pole and this is at the ground. The circus artist is climbing this way. And another condition is given, the angle made by the rope with the ground is 30 degree. So the ground level is this one and the angle between the ground and the rope, that is 30 degree. And the pole goes this way and the right angle triangle is formed. Let's label it as ABC. Now when you look at this ABC, here there is one angle and one side and another side, that is AB, we have to calculate. AB is the pole, height of the pole we have to calculate. So one angle and one side is there means we will be able to calculate any other sides of a right angle triangle by using trigonometric ratios. Here let's assume AB be the height of the pole. And we have to find out AB and we have AC. Once again, we have to find out AB and we have AC. So based on this angle 30 degree, this is the opposite side and this one is the hypotenuse. Here O, A, H and all I am not marking because we have already discussed and we are quite familiar with these terms O, A and H. Here we will do it mentally. So AB is the opposite side and AC is the hypotenuse. A relation connecting O and H. O and H is sine. So in triangle ABC, sine theta is equal to O divided by H. So here let's substitute it. Sine 30 is equal to O is AB, H is AC. So AB by AC. Sine 30 value, that is 1 by 2 is equal to AB by AC we have. AC is 20. And AB is unknown for us. So let it be same AB. Then AB is equal to this 20 we can take this way, cross multiplication. This 20 we can multiply with 1. So 20 divided by 2 is equal to, on the right side there will be only AB. So AB is equal to 20 by 2, then AB is equal to 10. So we have got the length of AB. So according to our assumption, AB is the height of the pole. So therefore the height of the pole is 10 meter. Move on to question number 2. The question is, a tree breaks due to storm and the broken parts bends so that the top of the tree touches the ground, making an angle 30 degree with it. The distance between the foot of the tree to the point where the top touches the ground is 8 meter. Find the height of the tree. As I mentioned before, you have to go through the question and form a right angle triangle. Here, a tree breaks due to storm and the broken part bends so that the top of the tree touches the ground, making an angle 30 degree with it. Let's draw a line segment, and here the dotted portion shows the broken part of the tree. The tree breaks from here and from here it is bending and it touches the ground. The top touches the ground. The tree bends from the particular point, that is starting of that green portion, and it touches the ground and making an angle 30 degree with the ground. That is the given condition. And the distance between the foot of the tree and the top of the tree, now that is at the ground, is 8 meter. Let's label A, D, B and C are the points we have labeled, and DBC is a right angle triangle, right angled at B, and AB is the original height of the tree. So let's assume let AB is equal to HB, the original height of the tree. Here, as per the given conditions, AD and CD are equal because AD is the broken portion. The tree breaks at D and from D, it is bending and the top A touches at C here. So AD and CD are equal. That is what the given condition, or from the diagram we can write. In triangle DBC, if you consider triangle DBC, here we need DB because the total length AB we need. For that purpose, we need DB first. So DB is the opposite side with respect to 30 degree, and BC is the adjacent side with respect to the same angle 30 degree. So O and A relation, that is tan theta. Tan theta is equal to O by A. Let's substitute it. Tan 30 is equal to O is BD and A is BC. So BD by BC. Tan 30 we know, that is 1 by root 3 is equal to BD by BC we have from the diagram, that is 8. Let's cross multiply it. BD is equal to 8 into 1. So 8 into 1 is 8. So the left side becomes 8 by root 3. That is here 8 by root 3 equal to BD. Right side is BD. Then in triangle DBC, again the same triangle we are taking, we need AD, but AD we cannot calculate because there is no triangle containing the side AD. But we know that AD and CD are equal. So if we calculate CD instead of AD, we can substitute. So with respect to the 30 degree angle, CD is the hypotenuse and we have a value 8 meter, that is BC. So with respect to 30, CD is the hypotenuse and BC is the adjacent. So the relation connecting adjacent and hypotenuse side is cos theta. And here theta is 30 degree. So cos 30 is equal to adjacent is BC and hypotenuse is CD. That is cos 30 value is root 3 by 2 is equal to BC we have from the diagram, that is 8 divided by CD is the required quantity. Cross multiply it. CD into root 3 is equal to 8 into 2, 16. From here CD we can calculate. CD is equal to 16 divided by root 3. CD and AD are equal. So AD we can write 16 by root 3. Then we can calculate the height. H is equal to AD plus BD. So let's substitute it. H is equal to AD we have 16 by root 3. BD we have 8 by root 3. So 16 by root 3 plus 8 by root 3. Since the denominators are same, common denominator root 3 we can take, numerator we can add 16 plus 8. That is equal to 16 plus 8 is 24 by root 3. Here when you check the denominator is an irrational number. So we cannot keep the answer like this. We have to rationalize the denominator. We have learned rationalization of denominator in class 9. Just to multiply root 3 in the numerator and denominator. That is 24 by root 3 into root 3, and in the denominator also we have to multiply root 3. That is equal to 24 root 3 divided by root 3 into root 3 we will get as 3. So 24 root 3 divided by 3 we have got the answer. Then 3 and 24 we can cancel, that is 8 root 3 meter. So the height of the tree is 8 root 3 meter. Let's discuss question number 3. The question is, a contractor plans to install 2 slides for the children to play in a park. For the children below the age of 5 years, she prefers to have a slide whose top is at a height of 1.5 meter and it inclined at an angle of 30 degree to the ground. Whereas for the elder children, she wants to have a steep slide at a height of 3 meter and inclined at an angle of 60 degree to the ground. What should be the length of the slide in each case? Here, according to the question, a contractor plans to install 2 slides for the children. For the younger children, she prefers to have a slide whose height is 1.5 meter from the ground, and for the elder children, she plans to keep a slide whose height is 3 meter from the ground. And the first slide inclined at an angle of 30 degree and the second inclined at an angle of 60 degree to the ground. So let's represent it in the diagram. So 2 slides she is preferring. The red one is for the younger children and the green one is for the elder one. And the first one is 1.5 meter height and the second one is for 3 meter height. And the first one angle is 30 degree and the second one angle is 60 degree. And here we have now 2 right angle triangles, and let's label it, the first triangle as ABC and the second triangle as PQR. Here, let ABC is the slide at 30 degree with length AC and PQR is the slide inclined at 60 degree with length PR. Once again, let ABC is the slide inclined at 30 degree with the length AC. So length of the slide is AC in the first case, and PQR is the slide inclined at 60 degree with length PR. So the length of the second slide is PR. So here we have to calculate AC as well as PR. In triangle ABC, we have here AB and AC is the required one. So with respect to 30, this is O, this is H. So sine 30 is AB by AC. Let's substitute it. AB is 1.5 and AC is the required one. Sine 30 value is 1 by 2. Cross multiply it. AC into 1, that is AC. 1.5 into 2, that is 3 meter. So the length of the first slide we got, that is 3 meter. And for the second case, we have to consider triangle PQR. In triangle PQR also, PR we need, PQ we have. So this is O and this is H with respect to 60. PQ by PR is equal to sine 60. Here the trigonometric ratio is sine because we have opposite and hypotenuse. So PQ by PR is equal to sine 60. Let's substitute it. PQ we have 3 meter by PR is the required one is equal to sine 60 value is root 3 by 2. Cross multiply it, that is PR into root 3 is equal to 3 into 2 is 6. So PR is equal to 6 divided by root 3. So let's rationalize the denominator. As before, we have to take the denominator and multiply it in the numerator and denominator. So 6 into root 3 by root 3 into root 3. That is equal to 6 root 3 divided by 3. And this 3 and 6 we can cancel it. That is 2 root 3 meter. Here the length of the slides are 3 meter and 2 root 3 meter because AC is one slide. AC we have got as 3 meter and PR is another slide for the elder children. So PR length we have got 2 root 3 meter. So the length of the slides are 3 meter and 2 root 3 meter. Move on to question number 4. The question is, the angle of elevation of the top of a tower from a point on the ground which is 30 meter away from the foot of the tower is 30 degree. Find the height of the tower. Here the angle of elevation, the term angle of elevation we have already discussed. Angle of elevation in the sense the angle between the horizontal and the line of sight when the object is above the eye of the observer. So a person is looking at the top of a tower from the point on the ground which is 30 meter from the foot of the tower. There is a tower and a person is standing 30 meter away from the foot of the tower and looking at the top of the tower at an angle of 30 degree. Then we have to find the height of the tower. So let's visualize the question. So there is a tower. A person is standing here and which is 30 meter away from the foot of the tower and looking at the top of the tower, and the angle is 30 degree. So we have to find out the height. So AB is the height of the tower, BC we have. So we have to identify the sides with respect to this 30 degree angle. This is opposite and this is adjacent. So the relation is O by A relation is tan. So by using tan ratio, we have to calculate the length of AB. So AB will be the height of the tower. So this question you will do it as homework. Move on to question number 5. The question is, a kite is flying at a height of 60 meter above the ground. The string attached to the kite is temporarily tied to a point on the ground. The inclination of the string with the ground is 60 degree. Find the length of the string. Assume that there is no slack in the string. Here, a kite is flying at a height of 60 meter above the ground. Kite is at a height of 60 meter from the ground. The string attached to the kite is temporarily tied to a point on the ground. The string is tied to a point on the ground. The inclination of the string with the ground is 60 degree. So angle between the ground and the string is 60 degree. Find the length of the string. So assuming that there is no slack in the string, means the string is very straight. That is what the meaning of the sentence. Let's visualize the diagram. So a kite is at this point which is 60 meter away from the ground, and this is the string of the kite and it is tied here, and the angle between the ground and the string is 60 degree. Here we have to find out the length of the string. Let's mark the points or the vertices of triangle, that is ABC. Now ABC is a right angle triangle, right angle at B. Let AC be the length of the string. As I mentioned before, AC is the length of the string. We have to calculate AC. So with respect to 60-degree angle, this one is opposite. 60 meter is opposite, or AB is opposite side, and AC is the hypotenuse. The relation connecting O and H is sine. So in triangle ABC, sine 60 is equal to AB by AC, O by H. So sine 60 degree is equal to AB by AC. Let's substitute it. Sine 60, we know the value, root 3 by 2 is equal to AB. AB is 60 and AC is the required quantity. So let it be same. So AC. Cross multiply it, that is AC into root 3 is equal to 2 into 60. 2 into 60 is 120. That is equal to AC is equal to, here 120 is on the right side and AC into root 3 is on the left side. So that into root 3, when it comes to the right side, it becomes divided by 3. So AC is equal to 120 divided by root 3. Then rationalize the denominator. Here denominator is an irrational number. So root 3 is there. Just multiply root 3 in the numerator and denominator. So 120 into root 3 divided by root 3 into root 3. So that is equal to 120 into root 3 divided by root 3 into root 3 is 3. So 3 and 120 we can cancel. That is 40 root 3 meter. So the length of the string is 40 root 3 meter. Next we shall discuss question number 6. The question is, a 1.5 meter tall boy is standing at some distance from a 30 meter tall building. The angle of elevation from his eyes to the top of the building increases from 30 degree to 60 degree as he walks towards the building. Find the distance he walked towards the building. From this question onwards, you have to take utmost care while visualizing the question, because from here onwards you will be getting two right triangles in one diagram. The question says a 1.5 meter tall boy is standing at some distance from a 30 meter tall building. In the first sentence, if you check, there are two conditions. 1.5 meter tall boy means height of the boy is 1.5 meter and height of the building is 30 meter. So he is standing away from the building, and from that particular point where he is standing, he is looking at the top of the building at an angle of 30 degree. Angle of elevation is 30 degree, means from that particular point, if you look up, he can see the top of the building at an angle 30 degree, and from that point he is moving towards the building and the angle of elevation changes from 30 to 60. So when he was away from the building, he has to raise his head to see the top of the building, and when he is walking towards the building, he need to raise his head more in order to see the top of the building, because he is very close to the building. That's why he need to raise his head more. So the angle changes from 30 to 60. The angle also will be changing or will be getting more. Here we have to find out the distance he walked towards the building. Let's visualize the question. There is a boy whose height is 1.5 meter standing away from a 30 meter tall building, and from this point he is looking at the top of the building at an angle of 30 degree. Here angle of elevation is 30 degree is mentioned. Angle of elevation in the sense angle between the horizontal and the line of sight. So the horizontal line comes here only because the eye of the observer is here. So the horizontal comes here. You need not draw the bottom line in the beginning because the eye of the observer is here. So the angle between the horizontal and the line of sight is 30 degree. And when he is walking towards the building, the angle of elevation changes from 30 to 60 because he need to raise his head more at this point. So the angle of elevation becomes 30 to 60. Then let's complete this diagram by drawing the parallel line which is below the horizontal, that is ground level. And let's mark the point A, B, C, D, E, F and G. And little more calculations we have to do here in the diagram itself. Here ED is 1.5 meter, that means GB or BG also 1.5 meter. Then BG 1.5 meter means AG we can calculate because the total length AB we have 30 meter. So AG can be calculated as 30 minus 1.5. This length we can reduce. 30 minus 1.5, that is 28.5 meter. So the calculations are over here on the diagram. Let's go for assumption. Let the required distance be CD. So CD is the distance he walked. And remember, the CD is not a part of any triangle, but instead of CD we can use EF, because from the diagram CD and EF are equal. Then let's take in triangle AGF. AGF. Here we have to follow a particular procedure. Since there are two triangles are there, you must have a plan. Either you go with a small to big or big to small. So small to big is always advisable. So small triangle you can take AGF. First triangle we can take. In triangle AGF, tan 60 is equal to AG by GF. Tan 60 we are taking because GF we need and AG we have. With respect to this 60, this is opposite, this is adjacent. So O by A relation is tan. So tan 60 is AG by GF. Let's substitute it. Tan 60 value is root 3 is equal to AG. We calculated here 28.5 divided by GF. That is GF is equal to, just interchange these two. GF will go here and root 3 will come back to GF position. So 28.5 divided by root 3. Then in triangle AGF, the bigger one, AGE, the bigger triangle we have to take in triangle AGE. Again, there also tan 30 only, because angle is 30 with respect to 30. This is the opposite, and this is the adjacent. O by A relation AG by GE. And here tan 30 value we know 1 by root 3. AG also we have 28.5 divided by GE we can split. GE we can split as GF plus FE, because we need FE only, and FE and CD we have already connected. So FE is the required quantity for us. So we can split GE as GF plus FE. Then GF plus FE is equal to, cross multiply it. GF plus FE into 1 is equal to 28.5 into root 3, it is written. Then we can just substitute GF value. GF already calculated here, 28.5 by root 3 plus FE is equal to 28.5 root 3. From here FE we can calculate. FE is equal to, this will go to the right side, that is 28.5 root 3. This plus going to the right side means minus 28.5 divided by root 3. From here 28.5 is common. Let's take it out. 28.5 into, in the first term there is a root 3 balance, minus here 28.5 going out means 1 remaining. So 1 divided by root 3. Let's take the LCM. 28.5 into, here common LCM root 3. If you take root 3 into root 3, that is 3 minus 1. So 3 minus 1 divided by root 3. That is equal to 28.5 divided by 3 minus 1 is 2. 2 divided by root 3 we have got. Now when you check the denominator, it is irrational, root 3. So just multiply root 3 in the numerator and denominator. So 28.5 into 2 already here. Into root 3 we are multiplying in the numerator, and the denominator there is already on root 3 before. So root 3 into root 3. That is equal to 28.5 into 2 is 57 into root 3 by 3. This 3 and 57 we can cancel. That is 19 you will get. So the final answer is 19 root 3 meter. So the boy walked 19 root 3 meter towards the building. That is the conclusion. Move on to question number 7. The question is, from a point on the ground, the angles of elevation of the bottom and the top of a transmission tower fixed at the top of a 20-meter high building are 45 degree and 60 degree respectively. Find the height of the tower. Here there is a building, height is 20 meter, and top of a building there is a transmission tower, means maybe a mobile tower, and a person is standing at a particular distance from the foot of the building, and he is looking at the top of the transmission tower at an angle of 60 degree, and looking at the bottom of a transmission tower at an angle of 45 degree. Here we have to find out the height of the tower. So let's visualize it. There is a building, height is 20 meter, and on top of building there is a tower, and a person is standing at a particular distance from the foot of the building, and he is looking at the top of the tower at an angle of 60 degree, and at the same point he is looking at the bottom of the tower at an angle of 45 degree, because if he want to look at the top of the tower, he need to raise his head more. That's why when he is looking at the top of the head, the angle is more. Then let's mark the vertices A, B, C and D are marked. Let AB be the height of the tower. So the green portion is the height of the tower. Then in triangle BCD, as I mentioned before, we are taking the smaller triangle first. In triangle BCD, tan 45 is equal to BC by CD, because the angle is 45. With respect to this 45, this is opposite and this one is adjacent. So O by A is tan 45 is equal to BC by CD. Let's substitute the values. Tan 45 is 1, BC we have 20, CD is unknown, so let it be same. So CD into 1 is CD is equal to 20 meter. We have calculated the length of CD. Then in triangle ACD, the bigger triangle we are taking ACD, the angle is 60. With respect to 60, this is opposite, means AC is opposite, CD is adjacent. O by A relation, again tan 60 equal to AC by CD. Let's substitute it. Tan 60 value is root 3. AC is the total length. We are splitting AC as AB plus BC. So just split at AC, AB plus BC divided by CD we have calculated, that is 20 meter. Then just cross multiply it. 20 into root 3, that is 20. Root 3 is equal to AB plus BC. From the diagram we can write 20. That is equal to AB equal to 20 root 3. This 20, when it goes to the left side, it becomes minus 20. Then from here 20 we can take common, that is 20 into the first term root 3 is the balance, and in the second term 20 is out, so only 1 remaining. So 20 into root 3 minus 1 meter. Then the height of the tower, that is AB we have calculated. AB is the height of the tower. So therefore the height of the tower is 20 into root 3 minus 1 meter. Move on to question number 8. The question is, a statue 1.6 meter tall stands on a top of pedestal. From a point on the ground, the angle of elevation of the top of statue is 60 degree, and from the same point, the angle of elevation of the top of the pedestal is 45 degree. Find the height of the pedestal. Here, a statue 1.6 meter tall. The height of the statue is given to us 1.6 meter. Stands on a top of a pedestal. Here, pedestal in the sense the base or support on which a statue is mounted. That is called the pedestal. A base or support on which a statue is mounted, that is the meaning of pedestal. And here we have to find out the height of the pedestal. Here the green portion shows the pedestal and the red portion shows the statue, and the height of the statue is given to us 1.6 meter, and we have to find out the height of the green portion, that means the height of the pedestal. And a person is standing at a particular distance looking at the top of the statue at an angle of 60 degree, and at the same point he is looking at the top of the pedestal and the bottom of the statue, both are same, here at an angle of 45 degree. So let's mark the points A, B, C and D, and there is a length of side AC we can calculate. AC is 1.6 plus BC. AB we know that it is 1.6. So AB plus BC is AC, that is 1.6 plus BC. So let BC be the height of the pedestal. So BC is the required quantity or required side we need to calculate. As before, in triangle BCD, the smaller triangle I am taking, in triangle BCD with respect to 45, this is O, BC is O and CD is A. So tan 45 is equal to BC by CD. Tan 45 value is 1 is equal to BC by CD. And here BC also unknown, CD also unknown. So let it be same, BC and CD. Then cross multiplying time CD is equal to BC. So here we have got a relation between CD and BC. Both are equal. CD is equal to BC. Then we have to go for taking the another triangle, the bigger one, ACD. Angle is 60 degree. With respect to 60, this one is the opposite one. AC is the opposite and CD is adjacent. So O by A relation, again tan 60 is AC by CD. Let's substitute it. Root 3 is equal to AC we can split as this. AC already we calculated, no need to split. If you want to split you can split, but already we have calculated here 1.6 plus BC. So just write it as 1.6 plus BC divided by CD. We can change. Actually CD we don't want. We want BC only. CD and BC relation is there. CD is equal to BC. So replace CD and substitute BC. Then BC into root 3 is equal to 1.6 plus BC, cross multiplication. We have to go for calculation. Let the like terms BC one side you can take BC root 3 minus BC. This plus BC, when it comes to the left side it becomes minus BC equal to 1.6. From here BC we can take out. BC if you take common, first time root 3 balance, second time BC is out, only 1 balance. So root 3 minus 1 equal to 1.6. From here BC is equal to 1.6. This root 3 minus 1 will come as the denominator, because BC into root 3 minus 1. When this into portion comes to the right side, it comes as division, 1.6 by root 3 minus 1. Here again root 3 minus 1 is an irrational number. We have to rationalize. Grade 9 we have studied rationalizing the denominator. Here root 3 minus 1 is there. We have to take the conjugate, that is root 3 plus 1. Multiply it in the numerator and denominator. So 1.6 into root 3 plus 1 divided by root 3 minus 1 is the denominator. Again multiply with the root 3 plus 1. So we are taking the conjugate and multiplying it in the numerator and denominator. That is 1.6 into root 3 plus 1 divided by, this is in the form a plus b into a minus b. A plus b into a minus b we have already learned, that is a square minus b square. So a square, a is root 3. Root 3 square is 3 minus b square is 1 square. 1 square is 1. So 3 minus 1. That is equal to 1.6 into root 3 plus 1 divided by 3 minus 1 is 2. So this 2 and 1.6 we can cancel, that is 0.8. When 2 and 1.6 cancelling time, we will get 0.8 in the numerator. 0.8 into root 3 plus 1 meter. Finally, the height of the pedestal is 0.8 into root 3 plus 1 meter. Next we shall discuss question number 9. The question is, the angle of elevation of the top of a building from the foot of the tower is 30 degree and the angle of elevation of the top of the tower from the foot of the building is 60 degree. The tower is 50 meter high. Find the height of the building. This question is a little bit of confusing because there are several words like top of a building, foot of the tower are repeating. So we have to go through the question very carefully and visualize it. The question, when you go through the question, it says about a building and a tower. The tower height is given to you 50 meter. So let's represent it first. That is, there is a 50 meter tall tower and there is a building. So the red portion is the tower and the green portion is the building. And the green portion is the building, in the sense the building height is unknown. So that is a required quantity which we need to calculate. Here, first line if you go through, the angle of elevation of the top of a building from the foot of the tower. The person is at the foot of the tower here and he is looking at the top of the building at an angle of 60 degree. And the second condition is the angle of elevation of the top of the tower from the foot of the building. So top of the tower he is looking, the person is at the foot of the building. The angle of elevation is 60 degree. The diagram is completed. Let's label the vertices A, B, C and D. And here the green portion AB is the height of the building. And here I am taking the bigger triangle first. That is in triangle BCD. BCD I am taking first. I am not taking ABC because when you consider ABC, both sides AB and BC are unknown. So the calculation will be little bit lengthier. So that's why I am taking the bigger triangle BCD first, because there is one side and one angle is available. Even if you take ABC, you will get the answer, but the calculation will be little bit longer. So I am going with the bigger one. Tan 60 is equal to CD by BC. Here 60 degree is the angle with respect to 60. CD is the opposite and BC is the adjacent. So relation between O and A is tan. Tan 60 is equal to CD by BC. Substitute it. Tan 60 value is root 3 is equal to CD. We have from the diagram, that is 50. BC is unknown. Let it be same. Then just interchange BC and root 3. Then BC will come to root 3's place. Root 3 will come back to BC's place. So BC is equal to 50 divided by root 3. Then in triangle ABC, the smaller one I am taking in ABC, tan 30. Here also tan only because O and A is necessary for us. So Relation connecting O and A is tan 30. 30 degree is the angle here in the triangle. Tan 30 is equal to AB by BC. That is equal to tan 30 value is 1 by root 3 is equal to AB divided by BC. That is, when you cross multiply AB into root 3, AB is equal to BC. So AB root 3 is equal to BC. Then AB root 3 is equal to BC we have calculated, that is 50 by root 3. Just substitute it 50 by root 3. Then AB is equal to this root 3 we can bring back to the denominator here, because just here it is in the multiplication. AB into root 3 is a multiplied form. When you bring that multiplied form to the right side, it becomes division. So root 3 will come in the denominator, that is 50 by root 3 into root 3. That is equal to 50 by root 3, sorry, 50 by 3. Root 3 into root 3 is 3. So AB is equal to 50 by 3 meter. Here the height of the building, that is equal to 50 by 3 meter. That is the final answer. Dear students, today we have discussed question number 1 to 9 from exercise 9.1 from the chapter Some Applications of Trigonometry. These word problems are very important, and while visualizing the question, you must go through each and every step very carefully. Hope it is clear for you all, and if you have any doubt, please note it and keep. We will discuss it during the online session. Thank you for watching.